So what can you fill in for me after watching the video? What of this can you fill in for me already? The equation. Okay, tell me what the equation is. X minus h squared over a squared, good. Plus y minus k squared over b squared equals 1. So the most common question I got on the video last night was, does it have to equal 1? Yeah. Okay. I think I said that in the video, but so I don't know if that was their question because some people are forgetting to put whether it's their question or someone else's question. But it's a question worth talking about. Okay. Does it have to equal 1? Yes. So let's think about yesterday's real quick. All right. What does a circle equal? The radius squared, right? What if I divided everything by that radius squared to get it to equal 1? What would be true about a squared and b squared? They'd be the same. Why does ellipses have to be different right here? It's not a circle, right? We go different different lengths horizontally and vertically, don't we? Okay? So that's why it has to equal 1, because we have to get these values so that we know how far to go horizontally and how far to go vertically. Okay? Does that make a little bit more sense? Okay. So where's my center? HK. Very good. What is the horizontal distance from the center to the vertex? A. Excellent. So this is A. What's the vertical distance from the center to the vertex? Good. B. And then this right here, the center, is HK. Any questions so far? Good, because you learned all this in the video last night, right? Good. Okay. So let's write the equation then. Well, won't it help to know the center and A and B first? Okay, so where's the center? 1, 2. And what's A? How do you know? You start from the center and count. 1, 2, 3, 4, 5. A is 5. B is 3. How do you know? And go which direction? Up or down? 1, 2, 3. So this is what I like to do when I'm writing equations of ellipses. I like to give myself blanks to fill in, because then I don't forget anything. Okay? So I have x minus 1 squared, and I have y minus 2 squared. And I'm done? Oh, I need my a and my b, right? Oh, so this is 25 because I got to square my a. And this is 9 because I got to square my b. Good. Any questions? All right, what about number 2? Negative 4, 1 is the center. Nice. A, 1, B, 4. So I have x plus 4 squared over 1. I have y minus 1 squared over 16 equals 1. Did you notice that I did both of those equations differently? On this one I filled in this and this, right? With my center, and then I went back and filled in A and B. On this one, what did I do? Numerator, denominator, numerator, denominator. Does it matter? No. Okay? It just depends. Do you want to get rid of your center first and then find A and B, or do you want to just do left to right, top to bottom? Totally your call. Okay? Where's my center on number 3? Excellent. A? Are you sure? Are you sure it's 6? Good. What about B? 2. What's my equation? X squared over 36, y squared over 4 equals 1. Okay? Now, why don't I have any parentheses here and here? The center's 0, 0. Tell me what you know on 4. Where's the center? 3, negative 2, are you sure? Good. Where's the center on the graph? Right 3, down 2. Okay? So what's A? How do you know it's 4? Square root of 16. Good. Go left and right 4 units. Left 4, right 4. What are those points? Negative 1, negative 2. 7, negative 2. Very good. What's B? How do you know it's 6? Square root of 36. Excellent. Up and down 6. 4, 5, 6. 1, 2, 3, 4, 5, 6. What are those points? 3, 4. 3, negative 8. Sketch the ellipse. Now look at my ellipse. Is it perfect? Do I expect yours to be perfect? What do I expect? It needs to be ellipse-ish. Okay? I would like it to be ellipse-ish. We good? E. Ellipse E. Negative 4 what? What's your proof that the center is at negative 4, 5? Oh, okay, because you can go the same distance up and down and the same distance left and right. Not only is that proof of my center, what else does that tell me? A and B, doesn't it? Yeah, what's A? 3 and what's B? 2. So what's my equation? X plus 4 squared over 9. Y minus 9 squared, or 5 squared, sorry, over 4 equals 1. I know I don't keep saying equals 1, but that's because we're putting ourselves a pattern down, right? But we need to make sure it does equal 1, correct? F. I was not asking you to raise your hand if that's what your grade is. Put your hands down. Chase. Dork. Where is the center? Well, does everybody see where F is? It's right here. It's Squidward's nose. Okay. 0.5 and 2. What's your proof that it's 0.5 and 2? Because you can go 1.5 sideways and 5 up and down. But that didn't that just give me A and B also? Oh, good. So what's my equation? To avoid confusion, am I allowed to write an equation of ellipse without this pattern written down already? Yes. That's just to help me, right? Just a little shortcut for me so I can fill in blanks. X minus 0.5 squared over 2.25 plus y minus 2 squared over 25 equals 1. Excellent. G. No, Preston, I was not calling you. I was just talking about ellipse G. It's okay. Center? Everybody see where G is? This one down here? Where is it? 2, negative 4. What's your proof? You can go up and down 2, and left and right 7. I wrote what you said. Does it matter if 2 is A or B? It does, doesn't it? Okay? So we got to go left and right first, and then go up or down. A is left to right, B is up or down. Got it? You know sometimes I just write what you say to see if you're watching. And you were. Good. What's my equation? X minus 2 squared over 49. Y plus 4 squared over 4 equals 1. Excellent. H, negative 6, negative 1. What is A? 1. What's B? 3. How do you know? You counted, right? Good. So x plus 6 squared and y plus 1 squared. Over 1 and over 9. Does this have to be here, guys? Can I just write that? Yes, but it's nice to have for some of us. Some of us can leave it off. It's fine. Either way, right? Okay, look. Are we good? You guys seem like you're getting this. Yes. What about 6? Where's my center? Whoa, whoa. You jumped really fast to 3. How'd you do that? These 2 points are already over 3, and it's the same overness, right? 3 what? It is now. 3, 5? How do you know 5? Because you went up as high as this point, and that y value is 5. Excellent. So this point is 3, 5. What's A? What's this distance right here? From 3 to 11 is 8. Very good. What about B? 6. I knew you'd get it eventually. From 5 to 11 in height, right? So that's a difference of 6. So what's my equation? X minus 3 squared and y minus 5 squared. Okay. Excuse me. Over 64 and over 36. Excellent. Equals 1. Thank you. What about the second part? Where's my center? Negative 12, 6. Good. So what's A? If this is negative 12, 6, how much further over do we have to go? 5. Very good. What about B? We went up 6 to get to here. And how much further down did we go to get to here? 4. So that's 10, right? So here's some arguments I heard earlier. Well, this is 6, but that's negative 4, so shouldn't it be 2? If we're talking about distances, right? This is 6, but this is 4, not negative 4, right? So what's my equation? X plus 12 squared over 25. Y minus 6 squared. Excellent. Over 100. Equals 1. Good. Questions? Okay, guys, does it feel like we're speeding through this? Why can we do this? We're prepared. Very good. We're prepared. Okay? So how do we graph A? So I need to go right 5 or left 5? Right 5. Down 1. How far left and right? 3 left and right. How far up and down? 2, 3, 4, 5. 1, 2, 3, 4, 5. What do I expect? Ellipses. Questions? Yeah, I doubt that. What about B? Where's the center? Negative 4, positive 5. How far do I go left and right? Right 4 and left 4. How far do I go up and down? 2 up and 2 down. Oh, that was too pointy. Sorry. I mean, not that you care, but... Oh, sorry. So what about C? Ooh, C is definitely tricky, isn't it? No? Right 4 up 6, that's not tricky. How far left and right? 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ooh, how far up and down? This is the trick, right? No? Good. It's just 1, right? If it's not there, excellent. Oh, this is a bad one. I'm sorry. Yikes. Don't look at mine. Do not make fun of my ellipses. Rude. So what about D? Where's my center? -3, -1. How far left and right? Ooh, this is the one that's tricky, right? Left and right too. How far up and down? Do you know the square root of 20 off the top of your head? No, but you should know that it's between 4 and 5, right? Because 4 squared is 16 and 5 squared is 25. 20 is between both of those numbers. Okay, what I'm trying to get you to realize, then for you telling me all these decimals is it good enough for me to know it's between 4 and 5? Yeah, I can't get too much more specific on this graph, can I? So I need to go up 4, 1, 2, 3, 4, and a little bit more, probably about halfway more, don't I? 1, 2, 3, 4, and about halfway more. Smarty pants. I didn't mean that as a compliment. Questions? Number 8. An ellipse has a working form with this equation. The center of the circle, duh, I could have told you the center of the circle. Right? You could have told them the center of the circle. But not only did they tell us in the sentence, they even put it on the graph. What's A and what's B? That's what they want, right? A is 9, B is 15. Okay? So what are the values of P, Q, R, and S? So if I'm trying to find P, point P right up here, I still need to go up over 6, but I have to go up 4 and then up 15 more, right? 6, 19. Very good. And in the same breath, if I'm finding R, I still have to go over 6, but from 4 I have to go down 15. Very good, -11. So what about S and Q? Am I still going over 6? No, I'm going over 6 and then 9 more, right? So 15, 4, because I'm still going up the same amount, right? So what do I know about S before I even start? I know it's something 4, don't I? Because I still have to go up 4. But from 6, I have to go back 9. So -3. Any questions? You good? So yesterday when we got to this point, we were done, right? Did you expect more today? The equation was a little more complicated, so hopefully, yes, you did, right? Okay, so there's some other stuff that is involved here, right? I'd like to talk about it, but I want to do this one first and talk some, and then this one first and talk some more, okay? With the exception of 2 days ago or 3 days ago when we did our vocabulary for each conic, have you ever seen the word major axis? together before. So can you tell me what it is in this problem? How do you know it's the longest one? Because you can use your logic, right? The major axis compared to the minor axis, the major one should be longer. How long is it? It is 12. Why is it 12 and not 6? A is 6. The major axis is all the way across. Very good. Okay, it's got to be all the way across. So what about the minor axis? Good. It's 4 because we have to count all the way from here to here, right? So now we need the focal length. They give you this beautiful, beautiful formula right here that when I'm doing this, I don't use. Not that it's wrong. It's really ugly to me. Not that I'm trying to be judgmental, but I would rather use this formula, except that's not right. Hold on. C squared equals A squared minus B squared. But is that the same formula, guys? If I took the square root of both sides, wouldn't I get this? Yeah, I just like this one better. It's not so messy. So some of this stuff I can do in my brain. So I know that leaves some of y'all out, but that's okay. Are you making a phone call in your calculator? Excellent, excellent. Okay. So how am I going to figure out C in this problem? What am I doing with A squared and B squared? I'm subtracting. I'm finding the difference. So 36 and 4? What's the difference of 36 and 4? 32. You guys know well enough by now to know that that is a perfectly acceptable answer, isn't it? Except when we have to graph it. We can't graph the square root of 32. We actually have to know that that's approximately 5.6, right? So where is that focus going to go? Where are those foci going to go? Left and right. How do you know it's going to go left and right? The foci are always on the major axis. Okay? Foci are on the major axis. And there's 2 of them. So this one would be 5.6 and 0. And this one would be negative 5.6 and 0, right? So let's have a conversation real quick. The foci give the ellipse its shape. If I pick this point on the ellipse and I take that distance and add it to that distance, that distance and add it to that distance, I get some value. We'll just call that value k, like a constant. Okay? But if I take another point on the ellipse, any other point on the ellipse, and find this distance and add it to this distance, guess what's going to equal? K. What if I take this point like here that's so close to this point, the focus, and add that distance and that distance? What am I going to get? K. Okay? Those are the values that give me the shape of K. One of the ways that I could choose to show you ellipses is I could get a thumbtack and put it right in that focus and a thumbtack in that focus and take a string and stretch it around these two and pull it tight. And keep the string tight all the way around, and guess what shape it would draw? An ellipse. Okay? The length of that string would be the K, wouldn't it? Or at least the part that's from each focus to the edge. That would be the K. All right? Let's do let's do B, and then we'll have another conversation. What's the length of the major axis in B? How do you know it? Because it's the longer. Even though it's up and down this time? Even though it's up and down. Okay? Whichever one is longer, that's the major. What's the minor? 6. What's C? What's the difference in A squared and B squared? Negative 16. Well, we got to know it has to be a positive number, right? So 16. What's the square root of that? 4. Where are my foci? Do I go over 4 again? Why would I go up 4? It's on the major axis, right? Very good. So this time my coordinates are 0, 4 and 0, -4. Look at my foci in this ellipse compared to my foci in this ellipse. Look how much closer they are to the edge. What shape does this have compared to this shape? It's skinnier and flatter, isn't it? These are a little further in, not a whole lot, but a little further in, and so this shape is, it's rounder, isn't it? Okay. So, is a circle an ellipse? Where are the foci of a circle? Both of them are right in the middle, aren't they? Okay. Any questions about that? It's that whole thing, is a square a rectangle, that kind of thing. Square is a rectangle. All squares are rectangles, but not all rectangles are squares. Same kind of thing here. Okay? Look at C. I know the major axis this time, and I know C. This time I need A and B. Can we go backwards? What's A? How do you know it's 13? So it could be half of the major axis, or it tells you. See? That's okay. What's B? Does it tell us B? No, but it does tell us C, doesn't it? So if I want to use C squared equals A squared minus B squared, what is A squared? So 169. I don't know B squared, but do I know C squared? What is C squared? 144. So if I subtract 169 from both sides to balance my equation, I get negative B squared equals negative 25. Can you tell me that that's 5 without doing any more arithmetic? Because you can see that, right? Yeah, I could divide both sides by -1. Yeah, then I could take the square root of both sides. But if you can see B is 5 from here, that's a really good thing. Nux. What about D? Oh, we forgot the equation, sorry. So what's my equation? Good. X squared on top, y squared on top. Under x squared is 169, right? 13 squared. And what's y under y squared? 25b squared. Equals 1. Thank you. What about D? Now are we good to go on D? Okay, what's the focal length? Difference is 64 or negative 64. We know it has to be absolute value of that, and then we take the square root of 64, right? Very good. So where are the foci? People asked me earlier why I say foci when it's one focus. Why don't I say foci? Well, I think that's too close to another word. I don't even want to go there. Okay. 3, 12, right? This is 3, 4, and I got to go 8 higher. So 3, 12, and 3 lower would be, or sorry, 8 lower would be 3, -4, right? Any questions? Kingston out.